Hello friends, today we'll be discussing about the machine tools. In machine tools we'll be discussing one of the very important type of machine tool that is called as milling machine. So just to go to the introduction part, so what is a machine tool? So machine tool is a machine on which the required amount of material is removed in order to get the required shape using a particular type of tool. So it is a machine, power driven machine, where using a particular type of tool, so the required amount of material is removed in order to give the required shape and size to the job. So machining is one of the mechanical operations. So machining operation is done on a machine tools. So in machine tools, so we got different types of machine tools. Just to name them: lathe, drilling machine, milling machine, slotting machine, shaper, etc. So we got a different number of types of machine tools. Each type of machine tool is used for a particular set of operation. In that series, we will be discussing a very important type of machine tool that is called as milling machine. So here today in this session, we will be discussing about the definition of milling machine, its classification, and we will be discussing in detail the construction and working of two types of milling machine, that is horizontal milling machine, vertical milling machine. So first, coming with the definition. So how we can define a milling machine? So if you take any milling machine, that is a machine tool, so definition will be almost running same, except depending upon what is the type of the tool that is used. So here, coming to the milling machine, it is a power driven machine where excess of material is removed, in order to get the required shape using a multi-point cutting tool. This is what the difference between other type of machine tools and milling machine. So if you take lathe, so difference between lathe and milling machine is that, so the tool. So here we use a multi-point cutting tool. Now if you take any type of machine tool, generally two types of tools are used. One is single point cutting tool and other one is multi-point cutting tool. So what is the difference between single point and multi-point cutting tool? So single point cutting tool is one will be having only one cutting edge. So as the material is removed, we will be having only one cutting edge. So that cutting edge, when it comes in contact with the workpiece, material is removed. That is single point, that is cutting tool. So coming to this milling machine. So milling machine is a power driven machine where using a multi-point cutting tool. So this multi-point cutting tool is called as milling cutter. So multi-point cutting tool is called as milling cutter. So using a multi-point cutting tool, the required amount of material is removed in order to get the required shape and size on the object. So coming to this multi-point cutting tool. So this is the multi-point cutting tool. So here, why we call this as a multi-point cutting tool is because, so you can see the sharp edges. So the projections, it is like almost like teeth. So these projections, tip of all these projections will act as a cutting tool. So this is called as a multi-point cutting tool. So here, as it rotates, so workpiece is fed against the rotating, that is tool. So every tip of the tool removes the material. So this is called as multi-point cutting tool. So this type of cutting tool is used in milling machine, and similarly in case of drilling machine also we use a multi-point cutting tool. Whereas if you take lathe, so where we use a single point cutting tool, where we will be having only one cutting edge. So here every tip of the teeth, so this is the cutter. So as it rotates, it removes the excess amount of material. So that is how we can differentiate milling machine from other type of machine tools. So one more important thing about milling machine is that, so here basically it is used to cut teeth on a gear. So gear is one of the important mechanical element which is used for, that is, rotation. So this is a gear. you can observe, so this projection part is called as the teeth. So these projections parts you can see, so these are all the projection parts, so these are called as teeth. So for cutting this teeth we use a milling machine. So this is the basic function of a milling machine. So for cutting teeth, that is in order to generate a gear, so if you want to manufacture a gear, so you should have teeth cut on the outer surface. For cutting this teeth we use this milling machine. That is the basic function of a milling machine. So other than this basic function, it is also used to generate other surfaces. It is also used to generate other surfaces. You can observe the figure, some of the figures I have written here. So this is in order to generate a plane surface, if you want to get a plane surface, we can use milling machine. If you want to cut a step surface, so where a step is generated, so you can see this is a step, this is a step, so then it is horizontal. If you want to generate a step face, once again it can be done on milling machine. Then T slots, so this is called as a T slots. Why it is called T slots? Because it is in the shape of a teeth. So this is the solid material. So this is the solid material in which we can observe a slot. So slot is nothing but the opening. So example for slot is that very simple example. If you take windows, sliding windows, so it will have the slots in which the window will be moving across or running across. That is called a slot. So that will be a U-shaped slot. This is a T-shaped slot. So this slot is provided in all the working tables of any type of machine tool. So that we'll discuss in the later part. If you take any type of machine tool, so a table will have T slots, so that we can use a nut and bolt and lock the workpiece. So if you want to generate a T slots, once again it is done by milling machine. So then if you want to generate an angular surface, here you can see this is a defined, so rectangular surface, it is a rectangular surface. So here you have to generate an angular surface. So when you want to generate an angular surface, once again we can go for milling machine. And then this is the gear teeth. So that's what I'm showing here. So this is the gear teeth. So when you want to cut teeth on a gear, we go for milling machine. So these are the different operations that can be performed on a milling machine. So once we know what is milling machine and the cutting tool used in milling machine and the different operations that can be performed on a milling machine, so we'll move to the classification of milling machine. So basically if you take milling machine, so it is classified into different types. The first one is column and knee type of milling machine. The first type is column and knee type of milling machine. So name given is column and knee type because if you observe the milling machine of this type, it will have two major parts, one is column and one is knee. It will have two major parts, one is column and other one is knee, hence the name is given as column and knee type milling machine. So this is the column and knee type of milling machine. So like that we have got special purpose milling machine, so gear cutting milling machine. So these are the advanced type of milling machines. So here at this level, so we'll discuss only one particular type of milling machine, that is column and knee type of milling machine. Column and knee type of milling machine. So here coming down in under a column and knee type, it is once again classified into two types. One is horizontal spindle milling machine and second one is vertical spindle machine. So horizontal spindle. So spindle is the rotating part on which the tool will be fixed. Spindle will be the rotating part on which the tool is fixed. So based on the direction in which the spindle is fixed, if it is placed on the horizontal axis, then it is called as horizontal milling machine. If it is placed on the vertical axis, then it is called as vertical spindle milling machine. Both come under column and knee type. So both will have column and knee as the major part. Along with that, spindle, if it is along the horizontal axis, then it is called horizontal spindle milling machine. If it is along the vertical axis, then it is called as vertical spindle milling machine. So we'll discuss individual parts of both types, that is horizontal spindle milling machine and vertical spindle milling machine. So This is a sketch of horizontal spindle machine. So sketch of horizontal spindle machine. So here name given is horizontal spindle because, so this is the spindle. So this is the spindle, you can observe. So this is the spindle. So spindle axis is horizontal. Axis is horizontal. Hence the name given is horizontal spindle machine. So coming to the looking at overall parts of this horizontal spindle machine. So major parts are, so first one is the base. This bottom one is called as the base. Then this is called as a column, vertical column. You can also call it as a vertical column. And then top one is called as overarm, which is placed above the vertical column. This is called as overarm. And this is the knee. So column and knee. That's why name given as column and knee type of milling machine. So this is the column, this is the knee. And this is the saddle. And this is the table. Over the saddle, a table will be fixed. And this is the spindle. And then this is this vertical shaft like structure that is called as, that is harbor. So this vertical shaft like structure is called as harbor. And this is the cutter. So milling cutter. This is the milling cutter. And this is the knee elevating screw. Knee elevating screw. And over the knee we have got this part that is called as horizontal guideways. And similarly on the front face of the column we have got one more guideways that is called as vertical guideways. See, these are the individual parts of a horizontal milling machine. Then coming to the individual function of the part. So bottommost part is called as base. So base is one which is supporting all other parts of the machine. That is the bottom one which we place on the ground surface, or it may be placed on a platform also. It is the bottom one, bottommost part, that's called the base, that is supporting and holding the entire machine. So since it is supporting and holding entire machine, it should be strong enough. So generally it is casted part. Casting is once again a mechanical process where metal will be heated and poured into the cavity in order to get the required shape. So this base will be casted part. So base casted part made up of cast iron. So it will be strong enough to take the weight of the entire machine and support the entire machine. That is the function of the base, that is the bottommost part of a horizontal milling machine. Then coming to the one end, so one end of the base will got vertical column, a strong vertical column. So normally this column and base will be an individual part. So in some cases it is shown as a two part. So in some cases it can be as individual part. So vertical column and base are a single part, So this is the vertical column. So normally vertical column, it may be, it will be circular in cross section. It will be circular in cross section, or it may be in other shape also. So this vertical column is one which is on one end of the base. So column is, function of the column is one which houses the entire driving mechanism. So here in this case, so here we will be having a driving mechanism inside the column. So that is the motor, the spindle. So spindle will be extended here. So as the motor runs, we will be having a driving mechanism which rotates the spindle. So column is one which houses the entire driving mechanism. So that is one which gives the motion or rotation to the workpiece in case of a milling machine. So this vertical column, once again, it is a casted part made up of cast iron. So casted part made up of cast iron. So that is the second important part of a horizontal, that is spindle milling machine. Then on the front face of this vertical column, so this is the front face. So this is the front face. So front face of the vertical column, we will be having a guideways, vertical guideways. So what is a guideway? So guideway is once again a slot which guides the movement, of the knee, So that is called as guideways. So it will be a projected part. So movement of the knee is supported or guided. So it is called guideways because it supports and guides the movement of the knee. So vertical guideways, it is called as vertical guideways. So here this is the projection part. That is the front face of the column will have vertical guide base. Function of the guide base is to support the vertical movement of the knee, That is the second important part, that is column. Then come to the topmost part, it's called overarm. So overarm is the topmost part that is placed over the column. So it is, once again, it is a part that supports that is your harbor. So this is the harbor, supports the arm along with the yoke. So yoke is the projection at one end of that is overarm. That is the function of the overarm. Then come to the very important part, that is the knee. So here one thing is very much important in case of column and knee type of milling machine is that, so it will have 3 direction movement, that is x direction, y direction and z direction. So 3 movements will be there. So the very important feature of this milling machine is that I can use these 3 rotations or 3 movements and cut any shape at any point of the workpiece, material can be removed. So 3 movements it will have, So coming to the very important part, so this is the knee part. So knee, so it is a part that is projected in the front face of the column. It is a part that is projected on the front face of the column. So this is the knee. So knee, once again, a strong part which is connected to the column. And it will have, it is heavy part, so it cannot be placed in between. So hence, to support that, we have got this knee elevating screw. So knee elevating screw. So here the knee will have vertical movement. You can observe this arrow mark. So this arrow mark shows that it can be moved up and down along with the guide base. So that helps to adjust the size of the job. If the size of the job is bigger, so I can move the knee and adjust it. So that is the one movement of the knee. So this knee, since it is a very big part, so it cannot be placed in between without any support. So that supporting function is done by this knee elevating screw. So when you move this, we will be having a handle like this here for movement of the knee. So as you rotate the handle, the knee moves in upward and direction. I can move it in upward direction. Similarly, I can move it in the downward direction. So the guide base guides the direction. Guides the direction, whereas the knee elevating screw supports the movement in vertical direction. Since it's a very big and heavy part, so supporting function is done by this knee elevating screw. So it can move above and below, that is in vertical direction. It can move up or down. So as you rotate the handle, it can be moved along the vertical direction. Now along the top surface of the knee, you can have, so this is called as the horizontal guide base. So knee has 2 movements. One is vertical movement. It can move along the vertical direction. It can move along the horizontal direction. So in order to guide the horizontal movement, we have got this horizontal guide base, similar like a vertical guide base. In order to guide the movement along the horizontal direction, so we have got the guide base, that is called as horizontal guide base. Now on the top surface of this horizontal guide base, we will be having a saddle. So saddle is one, so this is called as a dotile shape. It will be, saddle will be like this. It will have a dotile shape, whereas the top surface of the knee also will be dotile in shape like this. So if this is the bottom, of top surface of the knee, so this dotile shape will coincide with the dotile shape of the saddle. So that is the saddle. So saddle is the part which supports the table, which holds the table. So table cannot be placed directly on the guide base. Table cannot be placed on the guide base. So here the table will have the horizontal movement. So if the knee is moved along, that is a table which is placed on the knee has a horizontal movement. So the saddle will have the horizontal movement. So we'll be having handle in this direction perpendicular to the board. As you rotate, so the saddle moves. As the saddle moves, the table which is placed on the, that is saddle, also moves. Table is the part which holds the workpiece. I told that it is one of the operations performed is to get the T slots. You can observe this. So this is the T slots on the top surface of the, that is your table. So this is T slot. So this is the table. So table is the part that is placed on the saddle. So this T slots, over this T slots, I can place the workpiece. I can place the workpiece on which the required operation can be performed. And then on the ends, I can use a bolt and nut. I can lock it so that the workpiece will not move during carrying out the operation. That is the function of providing this T slots. So T slot is one which holds the workpiece, and the table can be moved along the horizontal axis. Table can be moved along the horizontal axis depending upon what is the size of the given job. Then coming to the one more important part is that the spindle. So you can see this projected part is the spindle. So spindle, normally it will be tapered. So it will be tapered like this on end. So this is a tapered surface. So this tapered edge goes inside the column. Tapered edge goes inside the column and locks with the, that is mechanism, driving mechanism. So it will be like this. It goes inside and then it will having a tapered portion. That is the spindle. So spindle is one which is connected to the motor using a driving mechanism. Once we switch on the machine, it starts rotating. That is the function of the spindle. So this is the direction of rotation. So very important, when you write the sketch, you have to show the direction, in which direction it is rotating. Now this is the, to the spindle, so harbor is connected. So this is the harbor. So what is an harbor? Harbor is nothing but the shaft. So when we got a lengthy shaft, so the shaft is called as a harbor. Shaft is called as harbor. This shaft is connected to the spindle. As the spindle rotates, shaft also rotates. The spindle rotates, shaft also rotates along with the spindle. Now on the other end, so we have got a part called as yoke. So yoke is one which supports the, that is harbor at one end. Since its length is more, when it starts by rotating, when it's rotating at high speed, so it may, the shaft, since if it does not have a supporting part at the other end, so it may wobble, so which the direction may change. Hence the yoke supports the, that is harbor at the other end. One end it is connected to the spindle. So and the harbor will be rotating in this direction. Now on the arbor, the cutting tool is fixed. So this is the cutting tool. So in case of milling, I shown the different operations are performed on a milling machine. So based on the operations, we have to use different types of cutting tools. So depend upon what is the operation you are performing, you can fix that particular type of cutter. So this is the cutter, that's called as milling cutter. That's called as a milling cutter. So these are the individual parts of a horizontal milling machine and the function of each individual part. Now once we know what is a horizontal milling machine, why it is called as horizontal milling machine, and the individual parts, its function of individual parts, so then we will move how an operation is performed in a horizontal milling machine. So here when you want to carry out an operation, so initially the workpiece is fixed on the table. Workpiece is fixed on the table and the workpiece is locked and the required type of tool is selected. As I told, depending upon what is the type of the operation you are performing, you have to select that particular type of tool. So that tool is fixed to the, that is harbor. Then using this knee elevating, using the rotational movement, so the knee is moved. As the knee is moved, so you have to make the workpiece to touch the surface of the tool. So if this is the tool, so the workpiece surface should touch the surface of the tip of the tool. So for that we use this movement. We can use these two movements, horizontal movement of the table and vertical movement of the column, and adjust so that the tip of the tip of the tool will touch the surface. So these are the initial preparations you have to do before starting the operation. So once these initial preparations are done, so you can switch on the machine. So as we switch on the machine, so the milling cutter starts rotating. So milling cutter starts rotating. So here the principle of working of a milling machine is that, so here the workpiece is brought in contact with the rotating tool, that is milling cutter. Workpiece is brought in contact with the rotating milling cutter. So as you switch on the machine, so the arbor starts rotating. As the tool is fixed to the arbor, so the tool also starts rotating. So the workpiece is gradually, so if you have got the rotating tool like this, so you have got the rotating tool like this. So as the tool rotates, the workpiece is made to come in contact with the surface. So as you move the table, so as the workpiece will have cutting edges, so as the workpiece will have cutting edges, so this is the cutter. So as the workpiece will have cutting edges, so this is the surface of the workpiece, so which is placed on the table. So as it starts, since here the spindle will be rotating, so along with the spindle, workpiece also will be rotating. So as the workpiece is brought in contact with the surface of the tip of the cutting tool, so material is removed. So required material removed until required shape is got on the job. So this is how operation is done in a horizontal milling machine. This is how the operation is done on a horizontal milling machine. Next, we'll move to the one more type of milling machine, that is called as vertical milling machine. So difference between horizontal and vertical milling machine is very much clear. So horizontal milling machine, spindle axis will be in horizontal direction, whereas in vertical milling machine, spindle axis in vertical direction. That is the basic difference between horizontal and vertical milling machine, and that is the reason why the name is given as vertical milling machine. So this figure refers a vertical milling machine. Vertical milling machine. So here almost all the parts are similar when compared with the horizontal milling machine. So you will be having a base, a vertical column. Instead of the, that is, overarm is not present and the harbor is not present. So the harbor is not present and the overarm is not present. Instead of harbor, you will be having a spindle head. Spindle head. So base, come to the parts. So bottommost part is the base. Once again, base is the one which supports the entire machine and which holds the entire machine. Hence it should be strong, and once again it is made up of cast iron. It is a casted part. Once again it is made up of cast iron and it is a casted part. Then on one end you have got a vertical column. Similar like a horizontal milling machine, you have got a vertical column. Now here you will be having on the front face of the vertical column, as usual you will be having vertical guideways similar to this horizontal milling machine. Function of the vertical guideways is guide the movement of the knee in vertical direction. Guide the movement of the knee in the vertical direction. So this is the knee. You can observe that this direction it can move vertically up or vertically down. Then to the front face of the vertical column, that is in front of the vertical guideways, we will be having the knee. On the top surface of the knee, you have got the horizontal guideways. Once again similar to your horizontal milling machine. So horizontal guideways will be having. So along on the surface, on the top surface of the that is horizontal guideways, you will be having the saddle, similar in the previous case. On the saddle you will be having the table. So table will have vertical slots. Table will have vertical, on the top surface of table will have vertical slots. So these are the common parts. So that is what we see when compared with the horizontal milling machine. So what is the change here? What is the change here? Now on the top edge of the column, here we have got a overarm and we have got a harbor to which the tool is fixed. But here, so on the top edge of this vertical column, you will be having the projection, so to which the spindle head is fixed. Here you can see that graduations. So this is a vertical head you can call. So that is the horizontal head. On the horizontal head, on the front portion we will be having the spindle head. Now one important feature of this vertical milling machine is that I can tilt this spindle head along any required angle. So I have shown here that one of the operations that's performed can be that cutting an angular surface. If you take any other machine tools, so cutting angular surface is not a easy job. So same thing can be done easily on a vertical milling machine. You can see this surface, this is horizontal. So this is an angular surface, So in that cases, this you can see, observe the graduations here. I can tilt the spindle head to the required angle. And I can lock in that position. So when I lock the spindle head in that position, so the tool will be also at a required angle. So when you perform operations, you get the angled surface or angular surface is generated on the workpiece. So this is the graduations that is given. So this is one important difference between horizontal and vertical milling machine. Horizontal and vertical milling machine. In case of horizontal milling machine, I cannot generate the horizontal surfaces. I can only generate vertical surfaces or flat surfaces. Whereas here I can generate angular surfaces. In case of vertical milling machine, angular surfaces can be generated. So this is the spindle head. So spindle head, here also will be having the spindle head that will be inside the column. Here it will be outside the column, that is projected path. To the spindle you can see the axis, vertical axis, that's what the name given as vertical milling, spindle milling machine. So to this spindle head, so this is a spindle, this is a spindle head to which the cutter is fixed. Cutter depends upon what type of operation you are performing. So here the cutter, the spindle will be rotating in this direction. So spindle axis there, spindle will be rotating to which the workpiece is fixed. That is on the table, workpiece is fixed. So this is the direction of rotation of the cutter. This is the direction of rotation of the cutter. So these are the individual parts of that is vertical milling machine. So one difference you have to observe, two differences. One is spindle axis is vertical. Second one, the spindle head can be tilted to any given angle. Spindle head can be tilted to any given angle, so that I can get angular, I can generate angular surface. So these are the two basic differences you have to observe between horizontal spindle vertical machine and vertical spindle milling machine. So once we know the individual parts, as usual, coming to the working. So working is similar when you compare with the horizontal milling machine. So here the given workpiece is fixed on the table. So given workpiece will be fixed on the table. So this is the table. I can fix the workpiece like this. So this is the workpiece that is fixed on the table. So here once again T-slots are used similar to horizontal milling machine to lock the job so that it should not come out of the table when the required operation is performed. So once you fix the workpiece on the table, so the workpiece is brought in contact, this surface of the workpiece is brought in contact with the surface of the tool. So for that we can use the knee movement, vertical knee movement and horizontal movement of the table. Using these two movements, we can adjust so that top surface of the workpiece will be in contact with the surface of the cutting tool. So these are the preliminary thing that has to be done before you start working on a vertical milling machine. So once these preliminary things that has been completed, so then you can fix the tool, select the type of the tool once again. So tool is not common in case of milling machine. So depending upon what is the operation you are performing, you have to select that particular type of tool. So select that tool, tool is fixed to the spindle. So then the machine is switched on. So once the machine is switched on, so surface of the machine, the spindle will be rotating, So the rotating spindle, the table is moved. When the table is moved, workpiece surface comes in contact with the tip of the tool. Remember here the tool, the workpiece is brought in contact with the rotating tool. Workpiece is brought in contact with the rotating tool. As it is brought in contact with the rotating tool, so the surface of the workpiece comes in contact with the tip of the tool and material is removed. once again table is moved until we until we get the required surface on the given workpiece. So the operation is continued. So once we get the required operation, the table is moved back, the knee is moved downward, the machine is switched on, and once again for the next cycle of operation, I can use the same tool if the same operation is performed. If I want to generate a different surface, I can select the different type of tool and continue the same operation so that the machining can be done on a given workpiece. Now this is how the working is done on a vertical milling machine. So this is the individual parts, function of individual parts, and then how the operation is done on a vertical milling machine. So overall, today we have started with milling machine. So what is milling machine? So difference between milling machine and other machine tools, then definition of milling machine, then classification. So before that, what are the different operations that can be performed? So along with the sketch, I have shown what are the different operations that can be performed on a milling machine. So then we have started with column and knee type. So why it is called column and knee type? So in that further horizontal spindle milling machine and vertical spindle milling machine. So construction and working of horizontal spindle milling machine, construction and working of a vertical spindle milling machine.